Hi guys, welcome back to my YouTube channel, and today we will be doing some more differentiation. This is an example of a implicit differentiation question. So let's get into it. So if we look at the question, we have x squared tan y equals 9. So over here we have x and y on the same side, so that means we have to use differentiation. So let me just write that down. We want to use implicit differentiation. There are other ways, but this is the easiest way of doing questions where the x and the y are on the same side. So we differentiate with respect to x. So we're still doing dy over dx. So x squared, if we differentiate this, it will turn into 2x, just chain rule. And then tan y, you should know this is a standard. Tan x, if we just had tan x goes to sec squared x. Like, you should know that as a standard one. But tan y, we will also have sec squared y, but then we also need to multiply it by dy over dx, because we differentiated with respect to x, and this is not an x, this is a y. So that's why we also need to have the dy over dx. Okay, so now we have these two. We would have our 2x. We would have to do product rule on this because there's two terms. So we have our 2x first of all times by the tan y plus the x squared if we don't differentiate it and we differentiate the other thing, sec squared y dy over dx, and the 9 obviously just goes to 0 because any constant always differentiates to 0. So that would equal to 0. So that's all differentiated, but we want to show this and we can see it's not quite in the right form. So what we can do is we can use some trig identities. So for example, we know that sec squared y, we know that 1 plus tan squared y would equal to sec squared y. And also, if we look at our original, we can rearrange this to find an expression for tan y. So we know tan y, we know the original was x squared, tan y equals 9. So we know tan y can be written as 9 over x squared. So then if we have tan squared y, which is what we have, because we need to get a form for tan squared y so we can make this into terms of x's. So tan squared y is 81 over x to the 4. So now we can sub this into here. So we would have 1 plus 81 over x to the 4. That would equal to our sec squared y. So what we can do now, we have our 2x times 9 over x squared because of our tan y. That's the first part, and our other part would be our x squared, lots of 1 plus 81 over x to the 4. And also we have our dy over dx, and this is equal to 0. So now if we do some rearranging, we can say that if we move this to the other side, we can say we have our x squared and our 1 plus 81 over x to the 4 dy over dx is equal to minus 18 over x. So now if we do some more rewriting, we can divide by all of this on the right hand side. So if I write down here, we can just get dy over dx on its own, and we would get minus 18 over x all over x squared 1 plus 81 over x to the 4. Then what we can do next, we can bring down the x if we divide by x to make it into a simpler fraction. We get minus 18 over x cubed 1 plus 81 over x to the 4. Okay, now next step, we can bring the x cubed, we can bring it to the top. If we have all of this, we can rewrite it. So if I write this again, this is the same as x cubed x to the 4 plus 81 over x to the 4. This is because all I've done is I've made the new denominator alike. So I've times this one by x to the 4 and times this top and bottom by x to the 4 to get this. Now we have this, we can cancel out the x to the 4 and x to the 3. So we would just have an x to the 4 plus 81 over x. Now we have this, we can put this back in to our dy over dx. So our top is still minus 18. Then we have over x to the 4 plus 81 over x. Okay, now we have that. Our dy over dx is equal to minus 18x over x to the 4 plus 81. Because we're dividing by an x, we're dividing again, which turns into a multiply. So the x comes up over here. And I think that is our answer. If we check 18x x to the 4 plus 81 minus 18x x to the 4 plus 81. So yeah, that's correct. So this is quite a tricky question, but it's only worth 4 marks. So we have to do some differentiation implicitly. Make sure we don't mess up with the missing out the dy dx. And then we also have to use some trig identity. So you should know this is a standard one. 1 plus tan squared y is equal to sec squared y. And then we also use this, which isn't an identity. This is just from the question. Our x squared tan y equals 9. But yeah, that was it for this video. I would really appreciate if you like and subscribe, and I will see you guys in the next video. Bye.